Okay.
Okay.
Hello, everyone, and welcome to this lecture on the subject of clean air legislation. I'm David Ball, the Chairman of the Power Industries Division Northwest Centre of the IMechE, and I would like to thank you all for joining our webinar lecture today. Before we get started, I would like to say a big thank you to Emma Pateman, the Senior Events Executive, and her team from the IMechE for helping to set up this session. It has been organised by the Power Industries Division Northwest Centre of the IMechE, and it is shared with the Greater Manchester area of the IMechE. The duration of the lecture will be 40 to 45 minutes, followed by 15 minutes of questions. You can type your questions in the question and answer box, and Simon Catherine, the Secretary of the Power Industries Division Northwest Centre of the IMechE, will endeavour to facilitate them after the lecture. For more detailed answers, please contact Natalie Bradshaw at the IMechE headquarters, and she will seek answers from the speaker and advise you by email. The lecture will be recorded and the video will be made available later. The presentation will explain how the current legislation regarding small to medium-sized combustion plants is not explicit and is inconsistent. The new regulations will change this so that they are regulated as per the large combustion plants, and the lecture today will clarify this so that it is easily understood. Our speaker today is Adrian Jones, who is a technician and safety specialist with almost 30 years experience working in the gas, processing, nuclear, biotechnology and power sectors. Adrian is employed as the Chief Safety and Environmental Consultant at Costain. Ladies and gentlemen, our speaker for this lecture, Adrian Jones. Thank you.
Okay, thank you very much for that, David. And first of all, I'd like to say thank you to Simon Catherine for asking me to give this talk tonight, and to the IMechE Power Group for arranging everything. I'm very pleased to be able to speak to you all. I remember it's probably about as close as I'm going to get to a Christmas lecture for the Royal Society or something along those lines, so I'll make the most of it. I guess that in this year, hopefully we've got a good attendance, and given that all the party season's probably off the map this year. Anyway, as David said, yeah, I've been working in industry for about 30 years now in various different sectors, which have all involved regulatory or safety compliance, and I've been with Costain now for exactly 7 years to the day, actually. And I work in Costain's front-end group, and I've been involved in some major projects with National Grid on the gas transmission network, alongside working with gas refiners and other importers. Also been involved in waste projects and water, and more recently with rail. One of the areas which is kind of relevant to this has also been some work which I did with the Environment Agency for management of waste gases for onshore facilities, and that was a research project, and that work became UK policy for that sector to help develop what was going to be considered as best available technologies. Anyway, moving on, just one quick slide. Sorry, I forgot to press play. So what we're going to talk about, as David said, is the MCPD. I can't quite claim that it's going to tell you everything about clean air, but it's part of the strategy of the government, and I suppose more widely the European Union, to address pollution, emissions, and control pollution in the atmosphere. And I'll explain where that sits more over in the wider regulatory framework. So that was my introduction for myself. I will just do one slide on Costain. I'm sure the vast majority of you will know about Costain, but a couple of quick words. So we've been around a long time, over 150 years. Traditionally, we've probably been seen in the big construction sector, but we are now, have been for a few years now, moved into smart solutions, particularly in the transport areas of rail and road. One of the projects I've just been working on is a warning system for pedestrian level crossings on the rail network. In the oil and gas sector, which is where I tend to be sat, we're now looking at much more at low carbon networks, hydrogen, carbon capture and storage, that sort of thing, as the sector moves forward. Anyway, let's get to the main event. So, as Dave said, this talk is about the Medium Combustion Plant and the Medium Combustion Plant Directive. So, first thing is to establish what is Medium Combustion Plant. Is anything between 1 and 50 megawatts. Now, that is the rated thermal input, as measured by the net calorific value of the fuel which is going in. So most of that energy in most systems will go up your exhaust pipe. So you may be looking at anything from 30 to 40% efficiency, and the rest of the energy is lost. So be careful when looking at your systems to not be caught out by using your motive power or your energy at the point of use. It applies to all types of fuel, broadly speaking, and it applies to fixed and mobile plant, but not vehicular type plant, as we'll see later on. Okay. So what is the need for the MCPD? As alluded to, there are lots of regulations out there at the moment, covering all sorts of aspects of emissions, pollution control. Principal one nowadays that a lot of you may well be aware of is the Industrial Emissions Directive, and that covers a number of areas, but it encompasses also the Large Combustion Plant Directive, which covers units with a net thermal input of 50 megawatts or above. Now, that's been in place for quite some time now, but there was a gap below that in the 50 megawatt and down area, and the MCP sort of fills that gap. And there's a lot of units in the country that go into that gap. But in a wider context, there is this pollution that is coming out of these units. It impacts our health, it impacts our environment, and it generally goes unnoticed. I'll give you some examples in a minute. But it has a big cost to the economy, and it's something which we have been addressing via the Clean Air Act, which came out a few decades ago and has been recently revised in 2019. And there's a lot of pressure on us to address those sort of things. So what are the impacts of pollution? Well, what we're talking about here tonight is pollution from combustion, and nowadays the principal problem is NOx. In the past, we have had issues with sulfur dioxides or SOx, but scrubbing on large systems has helped with that, and we've also got away from things like coal and heavy oil now to gas, which is much cleaner and less likely to produce sulfur oxides. But what you may see as consequences are smogs. So this is where NOx, oxides of nitrogen, which are produced in combustion, combine with volatile organic compounds and form particulates. Now, some people may remember about 8 or 9 years ago, the situation was very, very bad in the southeast. A friend of mine who lives down this way in London way, said you couldn't see the QE2 bridge because of the smogs that were caused then, a particular set of circumstances that came about with weather conditions, etc. The other thing you may get is eutrophication, or so you get enrichment of environments due to NOx and or acid acidification. Historically, that's probably been more to do with sulfur oxides, but it can contribute. But on a direct level, I said on the last slide that there are up to 40,000 premature deaths now that have been attributed to NOx and particulate matter releases. It's not the research is not able to completely separate them at the moment. But as a current example of where this sits, a young lady here that you see the photograph for her name is Ella Kissy Deborah. She died in 2013, and currently there is an inquest going through at the moment in London looking at her death, and this could be a landmark case for linking pollution with death. So she died of acute asthma attack, and she had multiple seizures and 30 visits to hospital over 3 years, and all of her attacks and seizures were linked to high pollution levels, NOx and particulate matter. So the outcome of that case could have profound effects for policy going forward. So where do we see, so hopefully that gives you some a clear indication of why we need to look at it. And one final point before I move off this slide, what we often think about, I suppose, is where pollution is in our local environment, but of course this sort of pollution is transboundary, so it may end up causing problems many, many miles away from where it's emitted. This slide gives you, this is some DEFRA data, gives you some indication of where NOx is being generated in the combustion processes. So you see road transport accounts for the biggest single component, which is no great surprise. And because of, obviously that because it gets trapped in urban environments, that's why the photochemical smogs and the ozone that is generated can be such a problem. But you see there the sectors in energy and manufacturing construction, which is where most of us will probably reside, accounts for about 37% of the overall NOx that's generated. In terms of numbers then, in the UK, these numbers seem to vary on different sources, but this is a DEFRA source from about 4 years ago. 30,000 medium combustion plant units. Quite a disparity there between the number which are routinely operated, and that's because many of those units will be used as standby plant. So, for instance, on the gas networks, where you obviously have to be able to move your gas at the right time, it's essential to have these units there, and they may do very little running time. They may not get used much beyond testing each year, or whatever frequency it is, but they are all still registered under the MCP directive. Most systems will fall between the 1 and 5 megawatts, and there'll be boilers in principally. So they'll be in buildings or for heating or large facilities, factories, or for utility generation, hot water, steam. And there's been an increase in use in recent years of diesel type generation systems, and this is covered by specified generators. So people are generating electricity typically to feed back into the grid, and that may be for covering triad periods when the price of electricity will go sky high. It happens on a number of occasions during the year, so it becomes very, very profitable to be able to produce during the triads or at peak times outside triads as well. Specified generators, I will mention some more on that later on. So the origins of the MCPD. So we had well, it's from Europe. So our friends that we're about to sail away from. I don't think this is in any way going to affect our legislation and regulations as they stand at the moment. But we started back in 2001 with the Large Combustion Plant Directive, and that was in place, covering, as it does now, units above 50 megawatts. The Eco Directive covered below 1 megawatt, and really that was more about efficiencies rather than direct emissions control amongst its other areas that it sought to deal with, so more like design standards and that sort of thing. But and then in 2010, the Industrial Emissions Directive came in, which absorbed the Large Combustion Plant Directive, and 6 other directives were all brought into that, including the IPPC, the Integrated Pollution Prevention Control Directive, under one umbrella. And that has continued to run since about 2010. But that left a gap in the landscape of a combustion plant, which has subsequently been filled by the Medium Combustion Plant Directive. As you can see, going back to the numbers that were involved, it represents a large number of units, and therefore quite a large contribution to potential pollution emissions. The timeline, so it came into force sort of 2015, 2016, and there was, as with all of these sort of directives, there was some transitional arrangements and time for operators to make changes, and the cut-off point for what would be considered new plant was 2018, end of 2018. So beyond that, you have a new plant. If you had your unit registered before then, you can take longer to comply with the regulations, and that will depend on the size of your unit. If you're a large unit, which is obviously going to produce more emissions, you're going to need to be fully compliant by 2025, and below 5 megawatts 2030. And there are some other exceptions in terms of sectors. So, for instance, in the gas transmission sector for the national grid, they have their units, even if they're above 5 megawatts, don't need to comply till 2030. How and what are medium combustion plants used for? Well, they're typically well, at least in the experience we have at Costain, we will see mainly gas turbines or gas or diesel engines used, and they're generally going to be used in our sector for motive power, for compression systems. The units which will be used at the lower megawatt ratings, probably going to be, as I was saying earlier, probably going to be boiler systems for heating, and they could be dual fuel or gas on their own, or they could be used for raising steam, that sort of for utilities use. Solid fuel boilers, probably they're dying out now, but there will still be examples of those. Building and district heating systems, so they're obviously going to be bigger boiler systems, and then just mentioning the mechanical drives again. And they can be mobile or fixed, but again, that doesn't include vehicular. It's where you may bring plant into a site to give you generation capacity or motive drive. And again, I'll mention the electricity generation specified generator, and that would include where you are taking power or generating power on site, which the regulator could have considered that you could have got from the grid. So you have to be a little bit careful if you are in that situation as to whether you may fall into the specified generator regulations as well. The exemptions, these are some general exemptions. If you are running your plant for less than 500 hours per year, and that's on a rolling average basis, then you are still subject to the MCP, but your emissions compliance changes. You're not required to comply with the emission limits that the MCPD puts on operation. The MCP doesn't apply to refineries and offshore installations. They have their own set of regulations which control their activities, particularly with refineries, which there is a BAT reference standard which sets out the requirements for refineries. Anything that's doing direct heating, so the flue gases, so brick kilns, are not required to comply. Biomass systems where that material which has been used has come from an animal byproduct, so horse manure, that it might be an example. I worked on a project quite some years ago for a different company that was doing a project for Horse Guards Parade, where they were trying to use the manure from the horses as a fuel stock for a boiler system. So that wouldn't apply. The next point there, LCP chapters and waste incineration chapters 3 and 4. So they are covered within the IED. So the LCP covers units over 50 megawatts, and that's a completely separate directive, and as is the waste incineration directive. So they have their own set of regulations and compliance requirements. I mentioned a minute ago about National Grid will have to comply, but they have got an extension for their units which are greater than 5 megawatts up to 2030. Of course, they've got a lot of units, I think something in the region of 60 or 70 gas turbines on the gas network, on the national transmission system. So they've got quite a lot of work to get all these units up to compliance. Some other exceptions are when you have fuel disruption or cold weather, you may have to switch fuels or run units which maybe are 500. You've got to stand by. You may need the extra capacity. So there is latitude for that sort of activity. I think that covers all those. So how does it work? Well, as I said, it covers units between 1 and 50 megawatts. And if you only have one of those units, it's quite nice and simple. If you have a 30 megawatt combustion plant, you will have the emission limits from the MCPD apply, and you'll be given a Medium Combustion Plant Directive permit. But if you have several of these units, maybe of smaller capacity, the regulator and the regulations state you have to consider whether they are actually installed together and share a common vent stack or windshield, or whether you could have done that as part of your design process. If they do share a stack, or if or more importantly, perhaps if the regulator thinks you could have done and could have designed it to do so, then you need to aggregate those inputs or those thermal loads. So two 20 megawatt combustion processes would become 40, or two 30s would become 60. Now, depending on the size of the units you're aggregating and how many of them, then you may then fall into you may then get pushed into the large combustion plant territory, and you may be regulated under that set of emissions, etc. So, but if you are, I'm going to give some examples in a minute, but if in order for you to fall into the LCP, you would only aggregate units over 15 megawatts or above. So if you had, this is my understanding at least, if you had four 14 megawatt units, you wouldn't have to aggregate. When you aggregate those and you go over 50, you would still be on an MCP permit rather than a LCP. But if they're 15 megawatts and above, you then go to an LCP brackets IED permit. So it starts getting a bit complicated, and it's also dependent on what other activities you may be doing on site as to whether an MCP permit is a standalone permit or it's part of an IED permit. The regulators for this is also not straightforward. It could be the local authority. I think if you're on a Part B permit under the environmental protection regulations, or it could be the national regulator, which in most cases, for us, will be the Environment Agency, or in Scotland, SEPA, and the equivalent agencies in Wales and Northern Ireland. Right, so I'm hoping the next slide starts to give you some idea of how this might work. Now, the aggregation rule does not apply to existing plants. So if you have two 20 megawatt systems, you would not aggregate those, and they would be permitted as MCP plant, MCP under the Medium Combustion Plant Directive. If you had a existing unit, i.e. before 2018, and a new unit post 2018, again both 20 megawatts, you would not aggregate those because of the existing unit rule. If you have two new units of 20 megawatts, you do aggregate those, and you get effectively one 40 megawatt system. Now, because that is below 50 megawatts, which is the limit for IED, that stays as a single MCP regime, under the MCP regime. If those two units were higher capacity, let's say 30 as it shows there, you would then have 60 megawatts of thermal capacity, and that would put you into the Large Combustion Plant Directive territory. So you would be regulated under a different set of regulations. Now, don't take these on here as absolute. There are other things that can affect this, and it starts to become very complicated. And it's something you really need to discuss with your regulator, which in most cases will be the Environment Agency, and they will be able to advise how they see your systems and whether they believe that it's reasonable to class them as being aggregatable by virtue of sharing a stack, and whether you go into the higher megawatt, higher thermal capacities by aggregation. And as I mentioned earlier, if it's below 15 megawatts, you don't need to count it as part of any estimation of thermal capacity for IED. You would only count that towards the MCP calculation. So what sort of control measures do we have with regard to meeting our emission limits? So the principal, as I mentioned earlier, the principal challenge these days with the medium combustion plant and the large combustion plant is controlling NOx. And if you've got old units, you can retrofit some of them to have wet combustion or dry low NOx, dry low emission control systems. The wet combustion and or the other control system will try and manage the temperature of the combustion process. The mechanics of the combustion process being that the higher the temperature, the higher the generation rate of NOx, because most NOx in combustion plant is generated by high temperatures. You can change the load profile. A lot more NOx is produced in combustion systems, particularly GTs and engines, when you drop the load profile. Anything sort of below 60 or 50 on modern machines, you'll potentially start to see an increase in NOx. So, as you'll see in it later on, the emission limits which are applied tend to be applied, at least in gas turbines, at higher load, above 70%. So, when you're sizing if it's a gas turbine type drive, you want to size it so that you don't oversize the system and then end up using the envelope, the performance envelope, very low loads, and which will mean that your combustion processes are difficult to control and you'll get more NOx generated. One option for, particularly as a retrofit, could be for existing systems, could be end of pipe abatement, and that would cover selective catalytic reduction or selective non-catalytic reduction of NOx. And you can also do that for carbon monoxide as well, which is a feature of the IED, but not of the MCP controls. There are some potential advantages with, I'm straying here into GTs more perhaps, but by putting on an end of pipe abatement system, you could actually allow yourself to have a system which produces more NOx, which is knocked out at the end of the pipe. The advantage of that could be that some of those drive systems without the DLE type controls or dry low NOx are actually more efficient. So your fuel usage could be a lot better, and the gains are not diminished by the operational costs of putting in the SCR. So it depends how you're going to run it. So running at lower temperatures is effectively what the retrofit and DLE systems will achieve. It's easier perhaps to do on a medium combustion plant because carbon monoxide is not yet regulated to a specific limit. Modern systems will have no problem meeting the MCP or IED emissions limit. So if you're buying new, as long as you size the equipment appropriately and use it in its right load pattern, it shouldn't be an issue. If you have a unit which is not going to be compliant, you can limit that usage. And if that works as your operational profile, then that's fine. But you do have to make a declaration to say that it is being used as a backup unit or standby unit. And if you exceed the 500 hours rolling, then you would have to report that to the regulator, and that could cause you a problem. And obviously, retiring the system, but that is, will for most people will not work with their operational requirements, or will mean that they have to replace it with something else. Emissions monitoring depends on the system. Risk assessments will need to be taken, but in general, if you are over 20 megawatts rated thermal input, you would monitor your system annually. If you're below 20 megawatts, that would be done every 3 years. It is important that you're able to monitor your system representatively and reliably. So these systems typically would not require continuous monitoring or predictive continuous monitoring to be applied. So what you're looking at for monitoring is coming along, as I said, once every 3 or 1 year, and taking physical samples from the flue gases from a position which shows that the concentrations of pollutants that you obtain from those flue gases is representative. So you take cross sections across the flue gas vent and to recognise procedures and through load profiles where that's applicable. If you are in a quality management zone area, the frequency at which you monitor, and indeed the emissions at which you are allowed to put out may be different as well. There may be additional requirements that are put on you. As I mentioned, at the moment there is no limit for carbon monoxide in the MCP. There is in the Large Combustion Plant Directive, but the only requirement in the MCP at the moment is to monitor your carbon monoxide levels. But that is going to be under review in a few years' time, and there was due to be a review of efficiency standards in 2020, but when I was writing this, at the time of writing, I couldn't find any information on whether that's been followed through on yet. One other point which I've not popped on here, but is that any emissions monitoring that you do, whether it's intermittent or continuous, the equipment you use will have to should comply with recognised standards as set out in the referred to as MCERTs, monitoring emissions to air, land and water certification scheme, which the government have set up. So that allows them to ensure that they're getting reliable information back. And this is a couple of slides just showing the key parameters which the MCP covers. So this shows here emissions from existing plant for greater than 5 and less than 5 megawatts. And if you focus there on the NOx, you can see that they're reasonably similar values. But when you come to the new units, is it going to work? Or have I click too fast? Right, bear with me there. What's going on here? Go to, apologies, it's gone a bit. Right, I'm not sure the animation is working properly on this slide right now, but what it's trying to show is that, at least in terms of NOx, there's quite a drop in emissions when you move from an existing plant to new plant, which is shown at the bottom. If you look at it in terms of so the natural gas, which is in the yellow boxes, you've gone from 200 to 250, you're now at 100. And this is a general combustion plant. The limits for SOx and dust do come down, but they're already reasonably well controlled from other historical technical advances or legislation which has existed in the past. So NOx has certainly been more problematic in recent times. And if you look at it for the next slide, which hopefully is for engines and gas turbines, you will see there that particularly for GTs, there's been a significant reduction in the emission limit values for NOx, and that represents improvements that have come through from units which fall within the Large Combustion Plant Directive, and which the same technology in dry, low emissions combustion plant is being used for GTs and engines at a lower scale. The same technology works there as it does for bigger plants. So this is all perfectly available in the marketplace, and this should not be difficult for users to go out and buy and install and meet the necessary requirements. the animation worked there. Operator responsibilities. Basically, you have to register your system, maintain it, etc. You have to give routine data to the regulator, be that the Environment Agency or the local authority. Key point there is about declaring if you have to give a written declaration that you won't use your system for more than 500 hours, and that you will have your system tested on a routine basis once every year or once every 3 years, depending on its size. But it's all fairly straightforward stuff. Nothing really there that's going to cause anyone any problems. Quick comparison between, I've talked about the LCP and the IED a lot as we've gone through, so it's worth having a quick comparison. So in terms of NOx again, which I'm focusing on, this is for gas turbines, I should say. The limits are exactly the same. As I mentioned, there's currently no carbon monoxide limit for a gas turbine, but there is for in the IED. You're only required to monitor it at the moment. The analyzer ELV applies in the IED, but not for MCP. An analyzed number being that it's derived from the BAT reference documents, where they recommend that you can actually achieve better than the 50 milligram limit. So the legal limit is 50 milligrams, but they expect throughout a year that you would tend to be operating below 35 milligrams, and that may get set by the regulator as your ELV. So typically for GT, you would expect to be running below 30 milligrams, maybe down at 20 when you're at an optimum load, and that allows you to go higher at various other points, as long as you stay below 35 on an annualized basis. So there's some differences on monitoring and permitting, but the key areas around the emissions limits. Now, regulation, as I've alluded to, it isn't straightforward. It can be very complicated. So you have the MCPD, 1 to 50 megawatts. You have the IED, which is 50 megawatts and above, but you have this grey area in the middle because of the aggregation rule, where your aggregated MCPDs, MCP units could fall into the IED, Large Combustion Plant territory. And in terms of who regulates you, I hope this is going to work. Right, yeah, the animation's packed up again. Right, the animation's not working there, but if you're in the MCPD, you could be regulated by your local authority, or it could be the Environment Agency. It will depend on the activities which are going on your site. Certainly, if you're in an office building, you're much more likely to be regulated, or a factory, much more likely to be regulated by the local authority. But if you're doing more industrial type processes, or you do fall into the IED, it will most certainly be the Environment Agency. So, but there isn't. I wouldn't say there was necessarily a hard and fast rule there. So you do need to have that consultation process. It's working now. So you hopefully see the overlap there in regulation as well. So finally, what might be the future? The regulation, the emission limits are only going to get tighter. They're not going to go to be relaxed. It's only going to go in one way. So I think when you're looking at buying systems now, buy well, I suppose, is the watchword. Buy something you think is going to give you headroom for the future. If you don't want to go down that route, then I think you need to plan to allow for abatement systems to go in. So that might mean leaving space on your plot for a selective catalytic reduction unit to go in. It's probably the lowest cost way of doing it. You effectively put some extra ductwork in. If at some stage in the future you need to do anything about your emissions because the regime changes, regulatory regime changes, it's not such a big a deal to come along and then put in an abatement system into the spool which you've put into your exhaust system. Alternative fuels are probably going to start to come into the picture a lot more, particularly with hydrogen. The hydrogen economy a network starting to get going. The use of electric drives. So it's going to become harder, I think, to demonstrate to the regulator that the use of a combustion plant for mechanical power is best available technology, in contrast to an electric drive, which will at source will still generate some emissions, although that is going to come down because of renewables. But the generation at source will be much more efficient, and so overall you will generate less. Greater integration, so there will be drives to have more combined heat and power systems, which will make that waste gas, that waste energy which I talked about at the start, will be recovered. And finally, I think there will be much more of an increased focus on best available techniques, which was something which was introduced with the Industrial Emissions Directive, but it applies across pretty much all of the environmental directives that are now out there. So let's quite a quick zip through, and there isn't a nice clean answer to any of what is in the Medium Combustion Plant Directive. Hopefully that's given you some overview of what's there, and some things to think about if any of those processes or apply to yourselves or your activities. So thank you very much, and if there are any questions, I'll do my best to answer them.
Okay, thanks, Adrian, for that presentation. For people listening, this is Simon Catherine. I'm the Secretary of the IMechE Power Industries Division Northwest Centre, and we have some questions which I'm going to put to Adrian. If anybody has any additional questions, then you should have the opportunity to enter them in the bottom right of your screens, I think. So I'll get on with that. We've got about 10 minutes, so we'll ask a few questions and see how we get on. Okay. So, Adrian, the first question that I've got is what proportion of operators of medium combustion plants do you think understand what their responsibilities are under an MCPD? I think the question is have they been contacted by the local authority, EA, and told what they need to do, or do they need to be seeing things like this to understand what their responsibilities are?
Well, I suppose in the experience that we've had in Costain, I think most of our clients do know that they need to address the MCPD. Where it gets tricky is whether, because of things like the aggregation rule, whether they fall into IED or their other activities that they may have on site, that the medium combustion plant that they have might get permitted under MCP emission limits, but is added to an existing IED permit. So there is that sort of complications. And then in the more nitty-gritty about how they then have to monitor and operate the system, that's where it starts to become a grey area for operators. Now, so in context of what our experience is, it's the awareness is there, but the understanding isn't necessarily clear to operators. And that's why I say it's vitally essential to engage with the regulator to get a better heads up. I suspect, and this is only me surmising, because we typically wouldn't get involved with this end of the market, but for this area of usage, but I suspect for people who operate boiler systems, which seems to represent most of the usage, there will be a lot of people out there who perhaps are not fully aware of their responsibilities under the Medium Combustion Plant. That said, there's been a lot of, it's been talked about for a long time, but if you're not somebody that engages in the right forums then it's entirely possible that you could have ignored, or some of this has passed you by. But I would have thought most people should be aware of it, and that the local authority should have written, but it depends how, what your relationships are and so on and so forth. But so they should have an awareness, but how they're acting on it is another matter. I mean, of course, for small systems, you don't have to comply for another till maybe even up to 2030. But that time will probably come around quite quickly.
Yeah, okay. And a question that's linked in with that was, what are the penalties for non-compliance?
Ultimately, you can get an enforcement action, so your operations are stopped if you're not complying with emissions, and you can't. There is in terms of, if it's a new system, you must comply. There's no two ways about it. You have to put it in comply. If it's an existing system, you have to comply by the dates. Whether there may be, as National Grid have had mitigating circumstances for the number of units that they had put through, they've had an extension for their systems which are above 5 megawatts till 2030. In general terms, you have to comply, and if you don't, you will be given an enforcement action against you, or to improve and sort it out, or you'll be stopped from operating.
Right. So it's being stopped from operating rather than a fine or a jail sentence.
I mean, they don't physically come in and put padlocks on your equipment. So if you continue to operate, and once you've been given an enforcement saying you can't, then you'll be looking at fines from that point onwards. Yes. It's you're in breach of your permit condition. Your permit would be revoked. So effectively, you've got no license to operate that plant.
Yeah. Okay. You mentioned recent smog event. Was it 2 years ago in London? And I don't know. The question is, why was that smog concentrated in London?
It was, as I recall, it's about 8 or 9 years ago, I think. It was springtime, and it's my observation in terms of weather patterns is that the weather patterns have become quite stable and quite pleasant in the early spring over the last 10 or 15 years, possibly linked to the warming climate. But as I recall, at that period of time, there was a lot of still weather in the country. There was very little stable weather conditions. And I think what happened is you got the NOx produced, and as I mentioned, most of that NOx that was causing the problem will have been coming from vehicle exhaust systems. So it's in and around urban areas, it gets trapped. And if you haven't got very much wind to push that, away and dilute it, then it stays in there. And if it then mixes in with volatile organic compounds, which may be produced from industrial processes, then you get warm weather, as we had at the time. To facilitate the reaction, you get the photochemical type smog event, and it was on the news for quite a few days, and it was really quite thick, and you can see it in any big city. If you're able to get up above, be it London or where we are in Manchester, you can see on warm days that you will get a haze above it. Some of that will be particulate, but some of it is also the sort of NOx and VOC reaction causing some level of smog pollution.
Mm-hmm. Mm-hmm. Yeah. Okay. Thanks. So if we go on to what are the what are the costs of modifications or bringing a new plant to meet the regulations? So I think there's a couple of questions around this, 2 or 3 questions around this, yes, we're reducing emissions of specific pollutants, but there are other consequences, aren't there? Cost of equipment, loss of efficiency, which results in more fuel being burnt, and that's not increased CO2 emissions, and increased costs, and I guess with an SCR, you may be introducing a chemical like ammonia to a facility that you wouldn't need to have on there otherwise. So what do you in balance, do you think this is appropriate? I guess bringing those 2 questions together.
Yeah, I mean, I think clearly the main, as you saw on the early slide, the main contributor is road vehicle traffic, but industry in terms of energy or construction or manufacturing is a big contributor. Is it appropriate? Well, there is clearly damage to people's health and the environment. I suppose if you look at it in context of sort of money we're spending right now to protect people's health, then yes, it is appropriate. And unlike, I suppose, what the situation we're going through at the moment, there is a net positive benefit to dealing with emissions and improving that a bit to our personal health, and just enjoyment of urban spaces and environment. How, in terms of costs, I mean, it's obviously dependent on size of the equipment, but we did a study for National Grid, an innovation study where we looked at retrofitting selective catalytic reduction to their systems, and it certainly, in many cases, is a viable and positive way to approach the problem. The great thing about an SCR system is it doesn't limit you in how you then operate the system if you design your SCR to correctly, because it can easily abate the NOx coming off your combustion unit. Retrofitting dry, low NOx or wet combustion systems is harder. It will very much depend on the plant and whether the vendors have supported that. I know some of the older GTs that we've worked with don't allow you to do that. Some do. You would be looking at small millions for that. If you're looking at replacement, I think Simon, you'll know more about this. If the frame size of your compressor your gas turbine is a similar size, and that might be a straight change out. But if it's not, then you're looking at new gas turbine enclosures or work to accommodate that new system. And of course, once you start putting new equipment in,
the speeds might not even be the same depending on what you do.
Yeah, and once you start putting brand new equipment in, you then start to need to look at the rest of your infrastructure, as we've found on other projects. I'm spending £10 million here. and I'm going to get 40 years of new life out of this, but how does that stack up with what I've got there now? Will that last that length of time? So I can't really say one figure, it's going to cost this much, but you're certainly, once you start replacing gas turbines or this sort of, which is the area we work mainly in, then you're talking millions, single millions up to double digits in that sort of scale of equipment. So yes, if you can get things like combustion system modifications done and that achieves what you need to do, then that's certainly a route to go. And in many cases, SCR will be cheaper than replacing the whole combustion system if you've got the space to put one in.
Yeah. Okay. No, thanks for that. I think we should wrap it up now, Adrian. So I've just taken the slides back to a photo of you smiling, which is good to see. And there is a LinkedIn address for Adrian there if people want to get in touch with him. That's available. But yeah, on behalf of the IMechE Power Industries Northwest Centre Committee, Adrian, I'd like to thank you for giving this presentation, which was was very interesting.
Well, I hope it was okay. It was the first time I've done a presentation like that where I can't even see my audience on Zoom or Teams or anything, and I kept wanting to hit the phone and say to check the line was still live.
It's a bit thankless, isn't it? Talking into a dead zone, so you can't get
thank you very much.
Feedback. So
thank you very much. I very kind of you to ask me to do it, and I hope people got something out of it. As I say, it is a complex area. In its way, the IED is much simpler because if you're in over 50 megawatts, you know exactly what who's going to regulate you and what permit you're going to get on this one set of limits, emission limits. MCPs is a bit more in between, and that can be problematic for some operators, or and you may not want to go into IED, and you may look for ways of trying to avoid that, and so on and so forth. So it is a bit more difficult, and so I'll come back to that point again. Talk to your regulator and get their advice, and that's very much the best way forward.
Yeah. Okay. Well, thanks for that. And there's just one last thing from me before we sign off. I've got a slide up now which shows the links to the IMechE online events website and the Near You, IMechE Near You for the Northwestern area. So I encourage people to keep up, to check into there and see if there are other things that they're interested in. I say we've shown Adrian's LinkedIn profile, but if there are any other questions, people want to get in contact, then Natalie Bradshaw which her email is natalie.bradshaw@imeche.org. I need to thank Natalie. She's been running things behind the scenes for this evening's event. So thank you for that, Natalie. But if people do want to get in contact, because of GDPR, we have to be a bit careful. But if you go through Natalie, then she can get in touch with myself or Adrian and get contact details shared or questions answered. So that's it for this evening. Thanks again, Adrian, for a very interesting presentation, and hope to see you people again at another event.
Okay. Merry Christmas, everyone.
Oh yeah, Merry Christmas.